Okay, good morning, good afternoon to everybody with us around the world. My name is Darryl Brown. I'm working with the rest of the team here over at Accion Labs and HEAL, and we hope you're going to be looking forward to enjoying this presentation. We're going to be talking a little bit about predicting the future and planning for failure. We all know about something is going to fail all the time, so you have to plan around that. So we're just going to give you some new ideas and new approaches. With us today, beside myself, we have Girish Muckai from my good friend and colleague over at HEAL Software, our partners. He's Chief of Sales and Marketing Officer based out the US, and Howard Zhang. He's Director of the Pre-Sales Group over at HEAL as well. So we'll each be covering a little bit here to keep it fresh and forefront of mind and keep you guys going. So what are we going to be covering today? Realistically speaking, we're going to try and give you a bit of insight into what HEAL is, but we're going to start off by talking about some of the challenges facing businesses and really the impacts of those challenges when there is failure. Then we're actually going to give you a couple of use cases and examples of successful companies that have worked around or found ways to get around some of those problems working with us, and then a brief overview of HEAL and why we're working together and what that brings to you and either your customers or your own businesses. Let's talk about some of these challenges. So when we're looking at challenges hitting businesses today, especially as I'd like to say post-COVID era, but where we're in this new era, should we say, the drive for continuous connectivity to applications and infrastructure is increasingly more important today than it was yesterday. It's not just about the revenue. If we look here at this chart and you see the speed, just looking at e-commerce, not even telecommunications or other businesses, it's expected to hit $6.54 trillion, which is great from a revenue perspective. But if all your revenue is basically tied to your systems and capabilities being available, it becomes risky. And we know that. It also, from an end user perspective, we see that typically if you look at e-commerce sites, only around 3% of those visitors convert to transactions. So if your sites go down, or doesn't matter whether you're doing insurance or whether you're selling applications, or you could be just moving normal consumer goods. Once the site goes down, that user's not coming back, probably for a month or even longer. I don't have any stats on that, but it used to be about a month. So those are areas to be considered. And if you look at that, when we're looking at the top concerns for digital commerce overall, beside the typical security concerns and verification of user identity, number 3 is abandonment. When your users go away, when your visitors go away, that could even be the same with your employees. Say a salesperson that is working with a customer. When that salesperson goes away, and they're going to be able to get that customer back, right? And with cloud does give us the ability to add more resilience. We can design for failure. We're supposed to design for failure. But in addition to that, it becomes more complex with increasing amounts of serverless architecture, with multi-cloud capabilities, with over 490 different services available just from the top 3 cloud providers. All that interconnectivity between those systems, those applications, makes it a lot more complex. It's complex enough for the developers to hook together all the APIs, let alone keeping an eye on keeping it up, right? So we can build in and prepare for failure. But the matter of fact is, we should be able to be aware if it's going to be coming. And we've seen major companies manage failure and prepare for failure, right? There's been a considering number of outages, even on Amazon, from their web services division. Web services division also had its own issues, in addition to all the CDN issues that we've seen out there. These are all areas of failure that have impacted others, consumers, and even the businesses that are depending on these infrastructure and applications out there. So we can prepare, but it would be great to know if that was coming. So what is the cost of failure? I don't really think you can put a price tag on it, because one failure for a smaller business, or whether you're a $100 million company, $20 million company, or a multi-billion-dollar company, each failure is going to cost you both in terms of revenue as well as in terms of customer satisfaction. But if you're looking at typical cost of downtime right now, Gartner's latest numbers was $5,600 per minute. So that's network downtime. And when we say network, that could be connectivity between the servers themselves, or it could be actual physical infrastructure. The average cost of a critical server outage for a business that is internet dependent, you're looking at up to $400,000 or more per hour. So these are big numbers, and these are the type of things that we need to plan for and we need to manage around. So with that, I'd like to put a little bug in your ear and, have you think about, what would you do if you could predict the future? What if you could predict that future? What if you could prepare for failure? Rather than designing for failure, what if you could actually prepare for it? So while you're designing for failure, what would happen if you had 15 minutes to spin up a bunch of servers that you had in another cloud? So rather than having them sat there and running, you could actually have them spin up for you because you knew something was coming down the line. And with that, I'm going to hand over to Howard. I'll give you a couple of examples of where we have helped customers overcome some of these issues.
Sure. Thank you, Darryl. Today, I'd like to really discuss about two use cases. The first case is an e-commerce company, except the product here that the customer is trying to sell is a home delivery service. It's delivering video streaming platform. This is in India, and we all know in India they love crickets, and everyone love to watch that. It's a big sports down in British countries or British colonial nations. And in this case, the application they're hosted on is it uses Apache Lamb Stack, and it's hosted on AWS environment. Some of the issues they had before having HEAL, before going with HEAL and Accion Labs, is that whenever there's a cricket match, the online streaming service will become extremely slow, just very slow, hang up a lot of people. Obviously, this leads to a lot of problems because these are paid subscribers, right? So if they pay money, they cannot watch the cricket matches. People get upset, they want refunds, and it just doesn't go well for the company. So they brought us in. We were able to install our agent within about 24 hours. So in one day, we're able to install our agents as needed inside the AWS environment. We were able to fetch data from the Lamb stack on AWS. We're able to fetch using our open telemetry platform. We're also able to ingest other critical information such as transactions, application, and other infrastructure metrics, and so forth. So we got that information, and with help of their application team, who gave us a little bit more insights, we're able to construct a very good application dependency map to figure out how each of the application components relate to each other and correlate and so forth. And from there on, we're able to generate lots of RCA, or root cause analysis suggestions, telling them what their issue is. And turn out that they have multiple issues. One of the biggest issues they had was that, well, only 10% of the issues they had coming in were actually genuine URLs. A lot of them were just spam. They were also having some issues in a database side, that there's some of the process that were getting blocked due to internal database design. So within few days, right? Actually, within a few hours after installing our agents, we're able to find out the root cause of their issues. And before you were there, it was taking them hours and days. And you know what? For today's economy, especially for internet e-commerce type of companies, delivery companies, it's extremely important to do things quickly. And in this case, this company didn't have any, their own, doesn't really have a big monitoring tool of their own before coming to us. They're going through logs to do, to do troubleshooting, and that's why it took so long. With our tool, they're able to get the solution up within the day, and we're able to find problems just minutes after our solution start to kick in. Next, please. All right, and the other use case I'll talk about is a large telco. In fact, one of the largest in the world. 2,500 stores in the US, 350 plus key apps. Now they have thousands of applications. Just the key applications are 350 of them. A lot of different applications, lots of different stores. And for them, they already have the best monitoring tools in the world, the best of breed, right? Lots of monitoring tools. So they don't have problem with observability. Now, instead, the issue they had was that they have too many tools to monitor. In fact, they get over 50,000 alerts a day. Now, granted, they have hundreds of people in operations who take care of these alerts, but if you do the math, right, there will be never enough people to cover 50,000 plus alerts a day. And that's just for the key apps, right? There are other applications they have that are not key, and these generates tons and tons of alerts too. What they wanted was that they want a tool, AI, to leverage AI, right, to machine learning AI, to figure out how to better correlate, how to better process all that information, to tie everything together. Again, their practical business problem was that they couldn't figure out of so many different things coming in, they couldn't figure out which alerts to really emphasize on. It was just too much, and they're fighting fires all the time, even for a big company. What we did for them was that we quickly built connectors. So we quickly built event the ingestion engines that would take in data from multiple sources. Unlike the previous case where we could just install an agent, in this case, they had their own tools. And that is perfectly fine with us, because one of the key values of our solution is to really correlate the data. And what do we do with that data? Well, we ingested all the events from different monitoring space that they had. We were told to reduce the amount of alerts by getting, correlate as much as we can, reduce the false positives we can, and then to predict future outages. In this case, using ML, we're able to figure out the context of alerts, and then first of all, deduplicate different alerts that had slightly different wording to them, but they're actually in fact the same alert. We're able to get rid of that, and then we're able to correlate the rest. And just by doing that, we're able to reduce the number of alert floods by between 40 to 60%. Now, that's actually quite a bit, because a lot of tools claim they do that, and they cannot do that very well. We were actually doing that. And then again, another thing we're doing for them was predicting early warnings. This is a huge, huge thing, because think about it. How do you be proactive if you cannot, if you're only troubleshooting after knowledge has occurred? So what we do here is that we actually, for them, we were able to look at the massive amount of data, figure out the patterns between the different metrics, some of the key metrics, performance metrics, and then the back-end metrics, some of the dependencies and so forth, figure that out, and then tell you before an outage has occurred. Of course, this is a huge project. We took, a couple of phases. Right now, we're actually on end of phase 2. We're going to phase 3. But the first wave, we're able to predict, test out the warning signals, which was very well, worked very well. And then the second phase, we're able to figure out right now we're reducing the number of alerts. And then the third phase, and this is to bring the whole automation thing, the dream into reality, will be to integrate with the existing orchestration solution and enable the auto healing capabilities. Thank you. Next. All right, Girish.
Yeah, thank you, Howard and Darryl. Good morning and good evening, everyone. So let me spend a little time on what the HEAL solution is all about. Now that Howard gave a couple of examples which illustrate the features of what HEAL and Accion can bring to enterprises globally. And also Darryl touched upon many of the issues and the repercussions of those when they're not addressed, and what would be the benefits if we can predict much better. So the HEAL solution in summary has three components. It's an AI ops tool, and observability is one key piece of it. We need to know what the environment is, which is metrics, alerts, events, topology, anything of that nature. And that can be brought in. Either the HEAL tool can have an agent and that can actually ingest data, or if there are additional existing tools that are available, as Howard mentioned in one of the two examples, we can ingest data from that. End of the day, it's all about if data is available, we leverage it, and collecting data twice is absolutely no, it's a no-no. So that's observability, and we can then understand the seasonality, how things behave, what are the properties, how is the workload, all that kind of stuff can be understood from that. Then the second piece is explainable AI. AI has been around for a while. Everybody does AI. But what we believe in is the right type of models that can then be used with the data, especially with the data that is useful. When we have large amounts of data, it is easy to get carried away and analyze everything, but that's not the point. Point is to use what is really relevant. And then number two, when we come up with a conclusion, we should be able to say why we are saying that there is a problem, especially when we are predicting. It's even more important. When we predict and say there is going to be a problem happening in 15 minutes, we need to be able to explain why we think there is a problem and what is causing the problem, what is the root cause. And that will give enough confidence for the operations team to act on it. If we are not able to show this and we just say there is a problem, operations team is not convinced and they may not act on it. So the explainable part is very important. And the way we approach this, we are able to find root causes. We are able to pinpoint where the problem is caused by. It's not just putting Band-Aid, but rather understanding the root cause of the problem. And then finally, all of this is good only if we can act on it. So the preventive healing part is once we come up with anomalies or problems that we think may happen, and we can explain why that is, then we can leverage a lot of existing workflow automation, ITSM tools, everything else under the sun that are already in existence to remediate, rectify, or fix these issues. So all these three, we believe, is the full cycle in order to make sure that the IT operations team can sleep in peace without worrying about what could happen, especially those of you who are in the operations side. You must have experienced many, many times the challenges, etc. So Darryl, if you can go to the next slide. Thank you. And HEAL and Accion, we've been working with a large number of analysts out there. And the HEAL solution has been quoted by Forrester and Gartner in a number of areas, especially in IT process automation, AI ops, APM, and modern technology operations. And we continue to work with many of the top analysts out there. And this is something, just want to reinforce what Darryl mentioned and what Howard touched upon. Every IT enterprise out there, and those of you who are right in the middle of this, I'm not trying to preach to the choir here, but outages are common. And oftentimes, we don't know where that is coming from, what is causing it. In the case of the e-commerce company that Howard mentioned, streaming causes the issue. And we don't know when that'll happen and why that'll happen. So we need to find out what the reason is. And all of this leads to very terrible user experience. And as Darryl mentioned, if you're an e-commerce user, consumer, and if your user experience goes down while you're searching for something or about to make a purchase, you're not going to come back for a very long time. You don't trust that site or that particular vendor that you're working with. So it has a lot of long-term repercussions. And thanks to social media People write about it very quickly if they have a bad experience, and it spreads like wildfire. And from an IT point of view, the application landscape has become exceptionally complex today. We have things that are deployed in on-prem in some cases, and in many cases, they're moving to a cloud or even a completely SaaS type model. And it's very hard to pinpoint where things are running anymore. So for the IT operations team, it's important to have a level of visibility into the application, into the performance, and into understanding what are the dynamics and what is causing what. So the correlations are very important. Causation is very important. Root cause is very important. And acting on large number of alerts. And as Howard mentioned, many of these companies that deal with large applications with a large number of consumers or customers or users, the number of alerts is over consuming. It is impossible to deal with it. So most of them are false positive, and knowing which ones are false positives and which one we need to chase is extremely important, especially to isolate the signal from the noise is combination of art and science, right? What we provide is the science behind it using machine learning. And then the art is learning from our experience over the past decade plus, working with large number of enterprises, both HEAL and Accion. We are fortunate to work with many, many verticals, enterprises that have been seeing all kinds of issues, and we learn from that, and we are able to apply that into the solution. And the current tools obviously are not enough, so we go to this. So our philosophy also is that in our typical machine learning tools, you train them for 1 week, 2 weeks, 4 weeks before they become productive and before they start producing accurate predictions and answers. Our customers have been telling us that that is not good enough. We need to be able to start coming up with useful information from day one. Of course, day one, we may not know everything. We may not be very accurate, but if there is something very obvious, we should be able to do that from day one. And that's what we do. So things like outlier analysis, things like obvious things with which we can come up with reasonable accuracy or reasonable confidence in the predictions, we will start from day one while we continue to train the machine learning models. We used to do a lot of unsupervised learning alone, but we realized that ain't good enough. So started doing more self-supervised learning, which in this particular case becomes a much useful approach. In a time series analysis, supervised learning really doesn't work by itself. So self-supervised learning is the approach that seems to work better. Second is we do a lot of transfer learning, which allows us to, as I mentioned earlier, learn what we have from other types of enterprises and bring that forward. Instead of looking at hundreds and thousands of metrics, we start with a smaller set that we think are the ones that are likely to produce the most value. And then we go from there. If that is not able to predict, we add more metrics as opposed to starting with hundreds and thousands and then reducing it. And then eventually by day 30, within a month, the models become exceptionally accurate and we can predict with a lot more confidence and also understand a lot of the seasonalities and things of that nature that happen with this. Darryl? And it's a busy slide, but I want a couple of takeaways from it. Number one, the HEAL solution along with Accion is an API-based solution. That means it fits into any environment out there. Number two, it can ingest data from existing tools that are available, if they are available. Otherwise, we can actually put our own agent and ingest data. Number three, it's all about coming up with with a very low noise prediction. I know that prediction is hard, but the point is we should be able to predict accurately and with confidence and with something that we can act upon. So the fourth piece is all about once we know and once human assisted AI, that means the operations person, once they bless what the root cause suggestions or the diagnostics that the tool comes up with, he or she or they can then act on it by triggering existing automation tools, workflow automation tools, runbooks, whatever they may have. So that is the fourth piece. In other words, there are 4 components. We want to ingest data, metrics on an ongoing basis, time series. So this keeps happening day in and day out. Number 2, we learn from that, the machine learning tools that we have, and we have really made it exceptionally sophisticated so that we can use what is important. Most of the data is useless. So it's all about figuring out what is useful. Number 3, come up with early warnings and things of that nature. And then number 4 is about visualizing. That way we can then tell the operations people what is really causing it in a very simple manner so that they can then act on it. So observability, explainable AI, preventive healing. Busy slide, but again, it talks about all the benefits of this, but I will hand it over to Darryl to talk about some of the other things.
Thank you, Girish. So some of the main benefits of HEAL that we see here is really the fact that it can boil down everything that's going on into a more understandable fashion, which is the main point. And as Girish keeps saying, like, the explainable AI is critical to it. With many, I think I'm losing my audio. Am I losing my audio? Am I good? With many of the different scenarios out there that are available, they provide a lot of busy information. One of the things that I really like about HEAL and our customers do is by being able to hook directly into the APIs and give you that real full stack visibility across the whole infrastructure, enables you to get a really good, solid, big picture, and over time, improve your overall infrastructure to make it more reliable and understand where parts of your business are negatively impacting. It's rapid to deploy. It starts working within, as you heard from Howard, within minutes of being put out there. And that makes a huge difference to the the results that you're going to get. Howard, do you want to have a quick on this one?
Sure, there are a lot of different things. This is just, again, a busy slide, but then this just summarizes some of the things that we do overall. I think some of the key takeaways from this slide is, multi-source, multi-format data ingestion. We have our own agents. We also ingest the data. This is, observability is all about ingesting data from different players, modern tool that already exists out there. And we do all that. And if there's something that, that's customized that we have not developed a connector for yet, as long as you give us some sample data, we were able to build that for you, typically between 2 to 3 weeks. The other thing, on the right-hand side, you have the early warning signals. Again, we talk a little bit about what do we do? So everyone say they do, AI, ML stuff. And everyone does that slightly differently. Some people use AI ML to define root cause of coding issues. Other people use it to organize information. We do it to really, really prevent outages. Ultimately, we want to reduce our MTTR. That is the core focus of our ML. And we do different things and we have our own way of doing that. First is early warning signals. And that, again, is, imagine, talk about being proactive. Proactive means that you do things before they happen, not you do things after they happen. And using our ML, we can actually figure out outages before they happen with a good degree of accuracy. It's not going to be accurate every time, but imagine if you can predict outages 5 minutes before they happen for 50–60% of the time. Imagine how much money and how much issue you can save, right? And then another thing is, deployment options. We know that there are different type of, different types of enterprise out there, big and small. Some of you guys use public clouds, others use on-prem. We support all that stuff. So, and then lastly, in the middle, it says anomaly, impact, accuracy score, and so forth. Girish talked about AI explainability, right? Explainable AI. A lot of people talk about AI, ML. You ask them, wait, what do you guys do? How do you guys calculate? How do you guys do all this stuff? Typically, people are kind of they're hiding because it's either too hard to explain or that it's too complex, or maybe the way they use it, it doesn't really work in every situation. For us, we're very clear about what we do. We have accuracy scores, we have relevancy scores, and other things that help users to understand exactly what we're trying to do here with our ML, which ultimately, again, is prevent outages. All right. All right, next slide. Thank you.
So one of the things about, Accion Labs and what are we doing together, but I think just to Howard's point, today, a lot of us are taught to, when we're building our infrastructure, to overbuild, to plan for failure. I think, one of the key takeaway with HEAL here is that it enables you to not just plan for failure, it enables you to get a better insight so you're more aware if failure is going to happen. Ultimately, that's going to reduce your overhead as well as the performance of the infrastructure that you're delivering or the applications you are delivering. And I think that's a really key takeaway to traditional after the fact resolutions versus being able to understand what is about to happen. So Accion Labs. Accion Labs, we're an innovation engineering company. So we work with companies like HEAL, as well as some enterprises, to develop software and innovate across their infrastructure. We currently have over 3,000 employees around the globe, and we're covering hundreds of different clients. What we like working with HEAL is we're both a partner of HEAL, where we're helping them with their go-to-market and their channel. Additionally, we work with HEAL to help them build their software and optimize it as well. So this is a true partnership in every shape and form. Our primary focus is, again, creating awesome software that does unique, innovative things and leveraging advanced technologies, in addition to our own accelerators to accelerate our customers' time to market. Why Accion and HEAL? Well, this is ours here. We think HEAL is very unique in the way it enables its customers to predict problems up to around 15 minutes before they happen. And I know, as Howard said, constantly trying to compress that and get more observability over time to basically, we shouldn't even be looking at MTTR at this point. We should be able to get to a point where there isn't really any outages at all because you're managing around them. The more of a window of expertise you get. Accion Labs, we deliver the skills and the expertise and the scale of the geographic reach to enable companies developing software or integrating software to put the two pieces of the puzzle together. So with HEAL, we help HEAL integrate their software into their customers' environments, as well as help HEAL build their software for their customers or work on the connectors, as Howard mentioned. And additionally, we help get HEAL to customers and prospects for them, as well as our own. And together, we think we make an excellent team. And with that, we come to the end of our webinar right now. And I think if anybody else has some questions, we can switch to some different types of questions and answer live. We will be having another webinar, which Rashad will be sending out a notification on. Yep.
Darryl, one participant asked if we can show a demo. I'm not sure if that is something that we have the time or prepared to do today, right? Howard and Darryl. We could always follow up.
Yeah, we can follow up with you for a demo, but additionally, we were planning another webinar to follow up on this, where Howard was going to go into more depth for those of you that wanted to really get into the meat of the tool, where this was more of an overview, or we can organize a one-on-one demo for you.
And happy to do. I think a demo usually, as I say, a picture is equal to 1,000 words. Yeah. So demo obviously much better in terms of showing at least understanding some of the capabilities, but happy to do that. Yeah, as you said, Darryl.
Actually, Girish, do we want to drop your email address in the chat box?
Yeah, let me do that right here.
So if anybody else wants to reach out, we'll put our email addresses in the chat box. This is mine. And we will get back to you. And so again,
Yeah.
thank you everybody for your attendance. Thank you, Girish. Thank you, Howard.
Thank you,
Yeah,
everybody.
thank you, Darryl and Howard, and thank you everyone for joining us. Hope you have a wonderful rest of the day or evening, wherever you are.
Thank you.
Thank you.
Cheers, everyone.